So let's go ahead and talk about exponents for a moment. Let's look at an example. So we've got 3 to the 4th power. Now exponents, just like multiplication, is just another way of grouping things. And the important thing is to always identify your base and your exponent. Okay, so why would we need to do that? Well, the base is telling us what we're multiplying, and the exponent's telling us how many times. So we've got a base of 3, and we have an exponent of 4, so we're going to have 4 3's, right? Okay, and again, you probably knew that, but just formally declaring it and really knowing that definition will be important when we look at some of these rules that we can use. So let's say that we have something like 3 to the 4th times 3 squared. So we have 3 to the 4th times 3 squared. Well, what does that really mean? Well, the 3 to the 4th means we have 4 3's, and the 3 squared means we have 2 3's. Well, if that's the case, why would we have to actually multiply it out like this? Because clearly we have a total of 6 of those 3's. Well, from our exponent, we can clearly see that, the original exponents, we can clearly see that we just added together those exponents, which makes sense. We are counting a little more efficiently here. That's all addition is counting anyway. So what if we had two different bases? So let's say we had 3 to the 4th times 5 to the 3rd. Well, once again, the 3 to the 4th means we have 4 3's, and the 5 to the 3rd means we have 3 5's. Well, unfortunately, none of these are the same, so we can't do anything with them. We cannot combine these together. Let's look at one more example that's similar to that. And that would be if we had something like this: 4 to the 2nd power raised to the 3rd power. We'll identify our base. In this case, I'm going to make the base 4 squared. And we identify our exponent, which tells us that we have 3 4 squareds. Well, those do have the same base, and we just learned that if we have the same base, we can just add up the exponents, which leaves us with 4 to the 6th power. Well, how can we do that a little bit quicker? Well, through multiplication. Really what we did here was we said we had 3 groups of 2 4's. Well, that's just 2 times 3. So let's go ahead and formalize these a little bit. So in this first example, if I had b to the m times b, the same base, to a different exponent, I know that's just b to the m times n. Plus n, sorry. In the second example, I couldn't do anything, so I'm certainly not going to formalize that into a rule. In the third example, though, I had b to the m raised to the n power, and that ended up just being b to the m times n. Now, I want to focus on this last one for just a moment longer. And the reason for that is we can work this backwards a little bit as well. So let's say that we had something like this. We had 7 to the 5th power times 3 to the 5th power. Well, if that's the case, then I can just rewrite this. I have 5 of those 7's and 5 of those 3's. So I can just rewrite it as 7 times 3 to the 5th power. Well, then that is just equal to 21 to the 5th power. So it's a little bit shorter, and this will become important when we talk about radicals a little bit later. But again, writing this out a little more formally, we can write that if we have a to the n times b to the n Well, we can group those together and just write a times b and then raise that product to the n power.